Today we are going to talk to you about enhancing the efficiency and attractiveness of the pellet use in blast furnace. And as we must be knowing that a small slag volume due to low gang content in the pellet as well as the more regular shape factors added by the reducibility advantages which cause due to high porosity of the pellet helps immensely to be used as a major body component of in blast furnace. These all enablers helps to control the burness profile of the blast furnace due to lower slag volume, which add a lot of advantages in pushing higher coal injection. Coming to the other advantages, there's optimization of MGO in pellet helps to balance out the sinter production. Pellet and sinter both homogenize with each other to derive a optimal softening and melting properties. Apart from this, a better phosphorus control is being executed with the help of the pellets also. These are basically outlook of a different lampor with the silica, alumina, phosphorus, and the most important part of its alloy. This is a very important illustration is for blast furnace operator to look into that what are the different body and compositions with respect to productivity can be speculated. So these graph, these illustrations basically guide the operator to derive that what sort of result he can derive with a combination of blast furnace body. Now coming to the important part of our presentation is basically the consumption of energy components in terms of carbonaceous fuels and emissions part. So if we come across a 1 ton of sinter production, then almost 50 kg of coprish is getting consumed along with a backup of 2.5 normal meter cube of coke oven gas per ton of sinter. Under these considerations, the sinter process is emitting a 225 kg of CO2 for production of each ton of sinter. And remember this that out of this 225, 60 kg is a contribution of calcination of limestone. So many times we come across the answer of our questions that why the gang content, especially silica component in iron ore input should be optimum, should be less. Because if we go through a higher siliceous input in our iron ore finds, then this calcination uh, uh, requirement will go on increasing, which will further increase our CO2 emission value. Coming to the pellet plants, as we can see that in Great Kaolin 20 kg coal along with 10 normal meter cube of natural gas is consumed for production of 1 ton of pellet. Exactly in the similar line, if we come across the traveling grade plant, then 15 kg of coal and 15 kg of natural gas is consumed. And if we go through the CO2 emission part, then almost 21 kg CO2 per ton pellet is produced. And It is also important to remember that in all pellet operation, additional 36 kg of limestone and dolomite would have to be added, thus emitting additional 28 kg CO2 per ton pellet consumed. This is the illustration where it navigates the operators regarding their burden uses and relative CO2 emission. So it is one of the very important tool as given in this slide. So finally, we can summarize what were the talk points in previous few slides. So we can say that this is the 1 ton 50 kg coke breeze and 2.5 normal meter cube COG consumption for production of 1 ton of sinter, whereas by consuming these 1 ton of sinter produces 225 normal meter cube of CO2 emissions, in which 60 kg contribution, 60 kg CO2 emission contribution is coming from calcination. And the similar line in the great kaolin or the traveling grate, almost 15 kg coal and 15 kg in natural gas in traveling grate, whereas 20 kg coal and 10 normal meter cube of natural gas in great kaolin is consumed. And if we consume see the CO2 emission part, that means in emission part almost 100 kg CO2 per ton of pellet is emitted, whereas in sinter is approximately, as we have discussed, 225. As for the energy consumption is concerned, we can see that 1 metric ton of pellet consume 50 kilowatt hour while ton of sinter. Electrical energy consumed is uh, 35. So here we can say that almost this is a good comparison of a pellet and sinter, and here also we can see that why pellets are more popular compared to sinter.